Good morning to all. Today we are starting Unit 2 of Advanced Java Programming, that is Event Handling using AWT or Swing Component. First, what is meant by AWT? AWT is the Abstract Window Toolkit. Then the first point is what is meant by event handling. Event handling is the mechanism that control the event and decide what should happen if an event occur. The mechanism have the code which is known as the event handler that is executed when the event occurs. Java uses the delegation event model to handle the event. This model defines the standard mechanism to generate and handle the events. Then source and the events are some of the basic terms which are to be understood before we look at the event handling. Then what is meant by event? Event, when you press a button in your program or Android applications, the state of the button changes from unclick to click. This change in the state of our button is called as an event. Events are generated based on how you interact with the GUI. For example, entering some text through the keyboard, moving your cursor, scrolling, etc. generate the event. Change in the state of an object is known as event. That is, event describe the change in state of source. Events are generated. Change in the state of an object is known as event. That is, event describe the change in the state of source. Events are generated as a result of a user interaction with the graphical user interface components. For example, clicking on the button, moving the mouse, entering a character through keyboard, selecting an item from the list, scrolling the page are the activity that causes an event to happen. Events are generated based on how you interact with the GUI. For example, moving your cursor, scrolling, that is the examples of generating the events. Then, in the declaration model, an event is an object. Event is an object that describes a state change in a source. Events generated by interacting directly, that is pressing a button, entering a character via the keyboard, selecting an atom in a list, clicking the mouse. Event generated by not directly interacting, when a timer expires, a counter exits a value, and operation completed. Then next topic is what are the types of event. Event are broadly classified into two categories, that is foreground events and background events. We are going to study one by one in detail. First one is a foreground event. Foreground event is the events which require the direct interaction of user. They are generated as consequences of a person interacting with the graphical components in a graphical user interface. For example, clicking on a button, moving the mouse, entering a character through keyboard, selecting an atom from list, scrolling the page are the examples of foreground events. Then next one is the next category of the events is background event. Those events that require the interaction of end users are known as background events. Operating the system interrupts, hardware or software failure, timer expires, and operation completion are the examples of background events. These are the two important types of or categories of event, that is foreground event and background event. Then next one is what is the event handling. Event handling is a mechanism that controls the event and decide what should happen if an event occur. These mechanisms have the code which is known as the event handler that is executed when an event occurs. Java uses the delegation event model to handle the event. This model defines the standard mechanism to generate and handle the event. Let's have brief introduction to this model. The declaration event model has the following key participant, namely source and listener. First, we have to see source. The source in an object on which event occurs. Source is responsible for providing information of the occur event to its handler. Java provides as with classes for a source object. In Java, nearly everything is an object. The button you press is an object too. Source is the object which generates an event. In other words, a source is an object which undergoes state changes. It also provides information about the event to the listener. We will talk about the listener in other half of to this post. Then event source descriptions. First one is a button that generates the action event when the button is pressed. Next one is checkbox source, that is a generate the item events when the checkbox is selected or deselected. Then the next one is the choice, generates the item events when the choice is changed. Next one is list, generates the action event when an atom is double clicked. Generate atom events when the atom is selected or deselected. Next one is menu item, generates action event when a menu item is selected. Generate atom events when a checkable menu item is selected or deselected. Then next one is scroll bar, generates adjustment events when the scroll bar is manipulated. Next one is text component, generate the text event when the user enters a character. Then next one is a window. Window generates a window event when a window is activated, closed or deactivated, de-iconified, iconified, open or quiet. These are our event sources. Basically, event source means what? A source in an object that generates an event. This occurs when the internal state of that object changes in some way. Sources may generate more than one type of the event. A source must register listener in order for the listener to receive notifications about a specific type of event. Each type of event has its own registration method. Each log in the event log key contains subkeys called event source. The event source is the name of the software that logs the event. It is often the name of the applications or the name of the subcomponent of the application if the application is large. You can add a maximum of 16,384 event sources to the registry. The security log is for system use only. The device drivers should add their names to the system log. Application and services should add their names to the application log or create a custom log. This is the deep descriptions of event sources. Then next one is a listener, that is event listener. The event listener represents the interfaces responsible to handle the event. Java provides us various event listener classes, but we will discuss those which are more frequently used. Every method of an event listener method has a single argument as an object, which is a subclass of event object class. For example, mouse event listener methods will accept instant of mouse event, where mouse event derives from event object. It is also known as event handler. Listener is responsible for generating response to an event. From a Java implementation point of view, the listener is also an object. Listener waits until it receives an event. Once the event is received, the listener processes the event and the return. A listener is an object that be notified when an event occurs. It has two major requirements. First, it must have been registered with one or more sources to receive notifications about specific type of event. And second one is it must implement the methods to receive and process these notifications. The methods that receive and process events are defined in a set of interfaces found in java.util.event. For example, the mouse motion listener interfaces define two methods to receive notifications when a mouse is dragged or moved. Any object may receive and process one or both of these events if it provides an implementation of these interfaces. Then the figure shows the listener steps or step listener. Then next one is AW2 event listener interfaces. First one is the action listener. This interface is used for receiving the action event. This interface defines the action perform method that is invoked when an action event occurs. Its general form is shown here, that is void action perform in bracket action event AE. AE means action listener. Next one is the component listener. This interface is used for receiving the component event. This interface defines four methods that are invoked when a computer is resized, moved, shown or hidden. Their general form are shown here: void component resize in bracket component event CE component listener. Then next one is the item listener. This interface is used for receiving the atom events. This interface defines the atom state change method that is invoked when the state of an item changes. Its general form is shown here: void item state change in bracket item event, that is IE. Then next one is key listener. This interface is used for receiving the key events. This interface defines the three methods that are key press, key release and key type. The key press and the key release methods are invoked when a key is pressed and released respectively. And the next one is the key type method is invoked when the character has been entered. For example, if the user processes and releases the key, three events are generated in sequence, that is key press, key type and key release. If the user presses and releases the home key, the two events are generated in sequence, that is a key press and key release. The general form of these methods are shown here, that is a void key press in bracket key event KE. Then next one, void key release in bracket key event KE. Void key type in bracket key event K. Normally there are three categories of key event, that is a key press, key release, key type. Key press is used when the key is pressed, key release is used when the key is released and key type is used when the character is typed. The next topic is mouse listener. This interface is used for receiving the mouse event. This interface defines five methods that are mouse click, mouse enter, mouse exited, mouse press and mouse release. First one is mouse click. The user click the mouse. Next one is mouse drag. The user drag the mouse. Next one is mouse enter. The mouse enter a component. The next one is mouse exited. The mouse exited from the component. Mouse move means the mouse is move. Mouse press means the mouse was press. Mouse release means the mouse was released. And last one is a mouse wheel. Mouse wheel means the mouse wheel was moved. This interface defines 5 methods we have seen already, we have discussed earlier. That is a mouse click, mouse enter, mouse exited, mouse press and mouse release. Mouse click means to press and release the point is mouse click. When the mouse enter a component is a mouse enter. When it leaves is mouse exited. Mouse press and mouse release means press and release the mouse respectively. Then next one is a text listener. Text listener is used for receiving the text event. This interface defines the text value change. The method that is invoked when the change occurs in the text area or text field. Its general form is shown here, that is a void text value change in bracket text event, that is a text. Then the next one is the window listener. The window listener event is generated when a user performs any one of the window related events, which are identified by many methods, or it includes many interfaces. There are 7 types of methods. These interfaces define the 7 methods that are window activated, window deactivated, window open, window close, window closing, window iconified, window de-iconified, window gain focus, window lost focus, window close, and window state change. The window activated and the window deactivated methods are invoked when the window is activated or deactivated respectively. If the window is iconified, that is the window iconified method is used. When a window is open or closed, the window open or a window close method is used. Then the other methods are also included in a window event, that are window gain focus, that means the window gain input focus. Next one is window lost focus, means the window lost input focus. Then next one is window state change, that is the state of window is changed. These are the additional methods or additional types of window events. The general form of these methods are, that is a void window activated, window event WE, void window close, that is a window event WE. Next one is void window closing, means window event WE. Void window deactivated in bracket window event WE. Void window de-iconified in bracket window event WE. Void window iconified bracket window event WE. Wide window open, that is in bracket window event W. These are the general forms of these methods. In this way we can write the events. Adjustment listener. Next one is adjustment listener. This interface is used for receiving the adjustment event. This interface defines the adjustment value change method that is invoked when an adjustment event occurs. The general form of the adjustment listener is as shown here is void adjustment value change in bracket adjustment event AE. It also includes the various methods, that is adjustment get adjustable, into int get adjustment type and int get value. Adjustable get adjustable means return the object that generated the event. Next one is int get adjustment type, that is means return one of a 5 constant that represent the type of event. And the next one is int get value, means return a number that represent the amount of adjustment. Next one is container listener. This interface is used for receiving the container events. This interface contains 2 methods, that are component added and component remove. First one is component added. When a component is added to the container, then the component added is invoked. And next one is a component remove. The component remove is used when the component is removed from the container. The general form of these listener are shown here is void component added in bracket container event java.util are and void component remove in bracket container event ce. Then next one is the mouse motion listener. This interface is used for receiving the mouse motion event. It defines, or this interface defines the two methods that are mouse drag and mouse move. Mouse drag means what? Multiple times, as the multiple time mouse is dragged, then the mouse drag method is invoked, and the mouse move method is invoked when the multiple times mouse is moved. Their general form as shown is here are void mouse drag in bracket mouse event me, void mouse move in bracket mouse event me. Then next one is the focus listener. This interface used for receiving the focus event. This interface defines two methods that are focus gain and focus loss. First one is focus gain. The focus gain method is used when a component to obtain key broad focus. When a computer loses the keyboard focus, then the focus lost is called, or focus lost is used. Their general forms are shown here are void focus gain in bracket focus event fe, void focus lost in bracket focus event fe. All these are the event listener interfaces. Then next topic is event source and their listener. All component except this, that is component listener, focus listener, key listener, mouse listener, mouse motional listener. These all types of listener uses this type of components that are dialog, frame, button, choice, checkbox menu item, list, menu item, scroll bar, text field and text area. First one is dialog box. Dialog is extend the window listener, frame is extended by window listener, button is also used action listener, choice is extended by item listener, checkbox extended by item listener, checkbox menu item is extended by item listener, list is extended by item listener and also action listener, menu item is extended by action listener, scroll bar is extended by adjustment listener, text field is extended by action listener and also text listener, and last one is text area. Text area is extended by text listener. These are the component that uses the types of listener. The next topic is the advantages of event handling. What are the advantages of event handling? The benefit of this approach is that the user interface logic is completely separated from the logic that generates the event. The user interface element is able to delegate the processing of an event to the separate piece of code. It also simplifies initialization and saves the memory. No need to add many handlers. Less code when adding or removing the element. No need to add or remove the handlers. DOM notification. We can mass add or remove elements with inner HTML. It also enables the event handling by the handling the objects other than ones which were generated by event and their containers. It clearly separates the component design and its uses. It performs the much better in the application where more events are generated. These all are the advantages of event handling. Then next one is the what are the steps involved in a event handling. Next topic is step involved in a event handling. The first step is the user clicks the button and event is generated. The next one is now the object of a concerned event class is created automatically and information about the source and the event get populated within same object. Then the next step is event object is forwarded to the method of register listen class. Then the next, the point method is now get executed and returned. These all are the steps involved in when we handle the event, that is in a event handling. Then the next topic is event classes. Event classes represent the event Java provides a various event classes, but we will discuss those which are more frequently used. The classes that represent the event are all at the core of Java's event handling mechanism. Thus, a discussion of event handling must begin with the event classes. It is important to understand, however, that Java defines several types of events and that not all event classes can be discussed in this chapter. Arguably, the most widely used event at the time of this writing are those defined by the AWT and those defined by the swing. What is meant by AWT? AWT means Abstract Window Toolkit. At the root of the Java event class hierarchy is an event object, which is in java.util. It is the superclass for all events. Its one constructor is shown here is event object. Event object src. Here src is the object that generates this event. Event object defines two methods that are getSource toString. First one is object getSource. The object getSource method returns the source of the event, and the next one is toString. toString is return the string equivalent of the event. These both are the event object defined types of method. The two methods are used to define the event object. Now we are discuss the event class description. In event class description, or the event class include action event, adjustment event, component event, container event, focus event, input event, item event, key event, mouse event, mouse wheel event, text event, and window event. We are discuss one by one. First one is an action event. Action event is generated when a button is pressed and an item or the list item is double clicked or a menu item is selected. Then the action event is generated. The next one is adjustment event. Adjustment event is generated when a scroll bar is manipulated. When the scroll bar is manipulated. Then the next one is the component event. Component event is generated when a component is hidden, move, resize, or become a visible. When the component is hidden, move, resize, or become a visible, then the component event is generated. Then the next one is the container event. The container event is generated when the component is added to or removed from the container. When the component is added to or removed from the container, then the container event is generated. Then the next one is a focus event. The focus event is generated when a component gains or loses keyboard focus. That is an input event, abstract superclass for all component input event classes. Means focus event is generated when the component is gain or losses by keyboard focus. Then the next one is input event. Input event is generated when the abstract superclass for all component input event classes. It abstracts the superclass for all component input event classes. Then the next one is the item event. Item event is generated when a checkbox or the list item is clicked, and also occur when a choice selection is made or a checkable menu item is selected or deselected. Then the next one is key event. Key event is generated when the input is received from a keyboard. When the input is received from the keyboard, then the key event is generated. Then the next one is a mouse event. The mouse event is generated when the mouse is dragged, move, click, press, or release, and also generated when the mouse enters or exits a component. When the mouse enter or exits a component, then the mouse event is generated. Then the next one is mouse wheel event. The mouse wheel event is generated when the mouse wheel is moved. When the mouse wheel is moved, then the mouse wheel event is generated. Then the next one is text event. The text event is generated when the value of text area or text field is changed. When the value of text area or text field is changed, then the text event is generated. Then the last one is the window event. The window event is generated when the window is activated, closed, deactivated, de-iconified, iconified, open or quit. Then the window event is generated. These all the events are including in a event classes. These all are about the event handling, event classes are we already discussed in detail in this unit. So thank you friends.